Hi everybody, this is section 6.7 and today we're talking about arc length. On a clock, what is the measure of the arc from 12 o'clock to 4 o'clock? Alright, well, let's take a look at this clock. So from 12 o'clock to 4 o'clock, we're talking about this angle right in here. And we know that there are 30 degrees in between each two numbers, right? So between 12 and 1, there's 30 degrees of rotation. 1 and 2, there's 30 degrees. 2 and 3, 30 degrees, and so on. So if we're going from 12 to 4, that would be 4 times 30 degrees, which is 120 degrees of rotation, right? So the arc measure from 12 to 4 is 120 degrees. Now, it says down below, notice that because the minute hand is longer, the tip of the minute hand must travel farther than the tip of the hour hand, even though they both move 120 degrees from 12 o'clock to 4 o'clock. So the arc length is different even though the arc measure is the same. So let's look at this a little more closely. So if we're looking at the path that the hour hand travels from 12 to 4, so this is the hour hand right here, points at the hour, right? And the tip of it would have traveled, let's say, that rotation, right, or that arc. But the minute hand, which is the longer of the two, it would travel, the tip of the minute hand would travel along an arc that looks more like this from 12 to 4. Well, obviously, the red arc is longer than the blue arc. If we straighten them both out and measured them, the red one would be much longer. So that's what we're talking about today. We're talking about arc length instead of arc measure. And even though both of these arcs would have a measure of 120 degrees because they're rotating the same amount, their arc length is very different. All right, we're going to take a look at these three examples to lead us to the formula for calculating arc length. It says here, what fraction of its circle is each arc? So in part A, they give us arc AB. And they ask us, arc AB is what fraction of circle T? Okay, well, we know circle T would be 360 degrees full rotation, right? And we can see that angle ATB, they're showing us, is 90 degrees. So that means that angle ATB, 90 degrees, out of a total of 360 degrees, well, that angle is 1/4, right, of the whole circle. So that means that arc AB is 1/4 of the whole circle. Let's go to part B. Arc CED is what fraction of circle O? Well, we can see that since CD is a diameter, right, we know that arc CED must be a semicircle, or half the circle, right? Well, that means it's 180 degrees out of 360 degrees, which is, again, 1/2. And now example C. Arc EF is what fraction of circle P? Okay, well, they tell us that arc EF is 120 degrees right there, right? So that's 120 degrees out of a total of 360 degrees, which makes it 1/3 of the entire circle. All right, so what does this have to do with arc length? All right, well, arc length is some fraction of the entire circle's circumference. If we knew the circumference of each one of these circles, for example, in example A, we would take 1/4 of the circumference to find the arc length of AB. In example B, we would take 1/2 of the circumference of the circle to find the arc length of arc CED. And in example C, we would take 1/3 of the circumference of the whole circle to find the arc length of arc EF. Now it's important to remember that arc measure is measured in degrees, but now arc length is going to be measured in units of distance. So it could be inches or centimeters or feet or yards or whatever. So now let's put this all together and come up with the formula for arc length. Arc length equals the arc measure over 360 times the circumference of the circle. Relating this back to our three examples, it's this piece right here that gave us the fraction of the circumference that would eventually give us our total arc length. Now let's put that formula to use. If the radius of the circle is 24 centimeters and the measure of angle BTA equals 60 degrees, what is the length of arc AB? So let's do a quick visual here. Okay, so we have a circle, and we have the measure of angle BTA is 60 degrees, and we have arc AB. Okay, so we must have a point A, and we have a point B, and the center of our circle is T, right? And they're telling us that the measure of this angle, although it doesn't look like I've drawn it that way, is 60 degrees. And they want us to find the length of arc AB. Well, if that angle is 60 degrees, then we know that arc AB has a measure of 60 degrees. So to calculate the arc length, I'll just say AL for arc length. I take the arc measure over 360 times the circumference of the circle. Well, they didn't give me the circumference, but they gave me the radius. So I can calculate it, 2 pi r, which is 24. Okay, so now I can simplify all of this, right? Arc length equals, well, 60 over 360 is 1/6 times 2 pi r. Well, 2 times 24 is 48, or 48 pi. I'll leave this in terms of pi, at least for now. And 1/6 times 48, well, that leaves me with arc length of 8 pi, and my units were in centimeters. So 8 pi centimeters. And as a decimal, that's approximately 25.13 centimeters. So there's an example of applying the simple formula for arc length.